Hello, I am Jonathan Hardwick and I am presenting our paper titled A Project-Based Curriculum for Computer Science Situated to Serve Underrepresented Populations. My fellow authors on this paper are Rebecca Bates, Gwario Silivia and Lynn Chase, and we are all professors at Minnesota State University, Mankato. So with this project-based curriculum, we have radically changed how we teach computer science at our university. And we have done this because we are trying to tackle a fundamental problem that we see, namely that the real-world challenges our students will experience when they graduate don't fit neatly into a single course or even a single subject area within computer science. To solve this, our new curriculum is centered around students completing 4 semester-long team projects in their junior and senior years and using these projects to drive and motivate their learning. We claim that this approach is good for students. This is supported by evidence from learning science on the effect of student motivation, on the effectiveness of student learning when they can see the relevance of new material, and on student feelings of autonomy and self-direction. We also have empirical evidence that this is good for students from integrated engineering programs at our university that have pioneered the project-based learning approach. We hypothesize that this curriculum should create better career trajectories for a much broader set of students. One thing we have learned from the integrated engineering programs is that project-based learning works for a set of students with a much broader range of backgrounds than has traditionally been represented in STEM fields. And this is something that we are emphasizing in the new computer science program. Our students will be graduating with the equivalent of 4 internships at a variety of industry partners. And in terms of their leadership abilities, our project teams are typically 4 students, with team roles being rotated, so every student in our program will have had the experience of leading a team for at least one 16-week semester. We have had some very gratifying reactions from industry. For example, here is a quote from Zalman Stern at Google, who is one of our industry partners for the current academic year. Again, our goal is to produce graduates who are ready to join any team in industry or academia, who have already had experience at that point of independent problem solving, who have had the experience of figuring out for themselves what they must learn in order to successfully complete a project, and who quite possibly have had the experience for the very first time of being part of a failing team. We're also very happy that our initial cohort has been majority women and majority people of colour, and we are striving to maintain that as we move forwards. Just to situate where we are, here is the new computer science program at Minnesota State University, Mankato. The project-based integrated engineering programs from which we take inspiration are also housed at Mankato, but are taught in the twin cities of Minneapolis and St. Paul, and in the Iron Range of northern Minnesota. Our project-based curriculum covers the final 2 years of a computer science undergraduate education, which means that incoming students have already completed their first 2 years, either at our own university or by transferring in. And because this is a 2+2 program, we can concentrate on working with feeder institutions who can help us identify women and people of color who will thrive with us. Although we have competitive entry, this is not driven by grade point average alone. We're interested in the whole student and especially in previous indicators of success on teams. Every student is also admitted as part of a cohort, and they will typically form close bonds and friendships within that cohort as they spend 2 years together on campus. Just to emphasize that the first 2 years is pretty standard, here's a screenshot showing the first 2 years from our 4-year plan. You can see that there is a classic computer science progression from a CS1 course to a CS2 course, followed by computer architecture and an algorithms course. This allows students to easily switch majors in their first 2 years, including to or from computer information technology and management information science. Computer science obviously has a more serious math requirement, including linear algebra and discrete mathematics. So this second year is typically where students make their decision. And then here is a sequential progression of the 4 semesters of our upper division curriculum. Every semester includes a team project, and there is also always a seminar class where all of our students are together. We also teach 2-credit core and elective courses, which I'll discuss on the next slide. And finally, all of our CS students will earn a math minor as part of their degree. The core courses and elective courses are taught alongside the projects. These are 2-credit half-semester courses, which allows us to dedicate more time to project-based learning. In the junior year, the core courses cover just enough conceptual material from the ACM outcomes that students can then put that material into practice on their own. And in the senior year, we offer elective courses that will often be tailored to topics needed by particular student teams, such as data engineering, human-computer interaction, or something from the field of artificial intelligence and machine learning. I mentioned student failure earlier, but obviously we set out to make every project successful, and we have a significant amount of scaffolding to try to achieve that. These projects are typically run as agile, with lots of client interaction, including a timeline and milestones, a faculty mentor on our side, a team contract that the students themselves create, and regular checkups to keep them on track as much as possible. The teams are vertically integrated, so they will contain students from multiple cohorts. We also put significant emphasis on professional skills and self-evaluation, and I will call out student reflection as a key tool here. Every week our students are submitting written reflection assignments on what they have learned, how they have learned it, how they can apply it, and how they might change in the future. And when a student does this every week for 2 years, we found that it is a very powerful tool for growth. As for industry clients, here is a summary for the current academic year. The sole big tech example here is Google, and we are excited to partner with teams at Google because they work with so many open source projects. So this is a great source of experience for our students. But the other thing that I will call out is just how many of our industry partners are early stage companies. These typically have a strongly exploratory nature, with many of them operating in an environment of uncertainty around user needs, market demand, or even the available technology stacks. So again, these are a very rich source of experience for our students, while also allowing our teams to easily see the relevance and contribution of their work. To wrap things up, this might not be the typical curriculum you would find from a traditional institution. And in fact, we were specifically told by our dean at the time to build something novel. To recap, we are adopting a successful pedagogy that has been pioneered by integrated engineering programs, and this approach has been shown to work well for engineering students from a very broad range of backgrounds. We intend to show that it works for diverse computer science students as well. We are project-based, centered around student cohorts, with a lot of industry interaction. We cram conceptual content into short courses that serve the projects, rather than the projects serving the courses. And we place heavy emphasis on the development of personal skills and growth vital for success in the field of computer science. One challenge for our university is that we have insisted that every team has 24/7 access to a dedicated project area. So what this means is that for 16 weeks, every team knows that there is one area in that room that is theirs and theirs alone, and this gives them a significant extra sense of ownership. And finally, we have competitive admission, but it is not purely GPA based, and we will work with feeder institutions to target prospective students who we believe will thrive in this unusual approach. Thank you very much for listening. Our contact details are here, including the homepage for our CS curriculum, and we would love to hear your questions.